On Thursday, January 20th, the next unified day of acceptance of the military equipment, during which Alexei Krivoruchko, deputy head of the Russian military department, announced that the Russian Aerospace Forces had received 17 new combat aircraft last year. And now, in particular, the Russian Aerospace Forces have been replenished with 2 new serial 5th-generation Su-57 fighters. The fighters were delivered in accordance with the plans of the Gagarin aircraft plant in Komsomolsk-on-Amur, NAZ, for 2021. According to sources, combat aircraft have tail numbers 51 Blue and 52 Blue. One of the aircraft was featured in a promotional video for NAZ. The Sukhoi Su-57 is a Russian jet with the latest features that perform the functions of both a strike aircraft and a fighter. The jet is also capable of destroying all types of air, ground and naval surface targets. It is also reported that this year the manufacturer intends to supply 4 Su-57 units to the troops. The first serial Su-57 made a test flight in December 2019, but a few days later it crashed as a result of a failure in the control system. Tests of the second serial fighter took place in October 2020. The aircraft was handed over in December of the same year, however, the official transfer of the Su-57 to the Ministry of Defense took place only in January 2021. The Russian Aerospace Forces should receive 24 Su-57s by the end of 2024. Their number will increase to 76 by 2028, all single-seaters, as agreed in the purchase contract. Therefore, the upgrades of the current phase of the Megapolis program should reach at least 52 aircraft. Sources in the Russian military-industrial complex have reportedly stated that an upgraded and modernized version of the Su-57 is to begin serial production. The modernization is part of the Megalopolis development program. According to TASS, among the main improvements of this new Su-57 is the incorporation of the second stage engine, the Izdali 30, and the renovation and upgrade of the cockpit, probably to unify as much as possible the production of the Su-57 with that of the S-75 Checkmate. Recently, Russian media reported that work was underway on technologies to enable various functions of the Su-57 to be controlled by voice and sight. It is not known at this time whether the aircraft to be delivered starting in 2025 will have these capabilities. The TASS informant also clarified that the modernization resulting from the Megapolis research and development project is designed for the single-seat Su-57 fighter. Some time ago, the idea had been circulated that the Su-57 fighter will also be designed in a 2-seat variant, first only for export, but then also to perform missions that may be too demanding for a single pilot, such as controlling a swarm of Okhotnik B combat drones. The Russian Air Force's opinion may be changing about the need for a 2-seat Su-57 due to the emergence of loyal wingman unmanned combat aircraft, which pilots will have to command and supervise, as well as control their own aircraft. One likely modification relates to the aircraft's hydraulic drive, which will be replaced with an electromechanical one. The first test flight for the updated Su-57 is scheduled for 2022. The purpose for carrying out such an upgrade is to reduce future maintenance costs and increase the efficiency of the aircraft. The switch to an electromechanical drive will also offer greater protection to the booster. Meanwhile, lowering the visibility of the platform to radar, optical and infrared detection will need to be finally resolved, while the upgraded engine may become a later addition. Since Soviet physicist Petr Yefimtsev worked out the fundamentals of stealth aircraft theory in 1962, the US has become the undisputed global leader in the use and application of stealth technology. Moscow has only recently attempted to play catch-up in this field. In essence, radar stealth is achieved by scattering incoming electromagnetic radiation or absorbing it via a protective coating. Even under the best circumstances, some part of a radar's beamed radiation energy returns, having directly bounced off the stealth craft's surfaces. Yet, at large distances, this echo will hopefully be small enough to be perceived by the radar's sensors operators as nothing more than electromagnetic noise. Consequently, the smaller the distance between the radar and the invisible aircraft, the greater the likelihood of the plane's detection, which has spurred the invention of special absorptive coatings to further limit how much of a signal returns to the radar receiver. The formulations of the coatings used in stealth aircraft in the US, Russia, and China remain classified. Though it is known that these are polymeric materials with carbon inclusions designed to absorb wave energy. According to Vladimir Tuchkov, writing in an article for Voyeno-Promyshlenny Courier, the designers of the Su-57, however, added 4 more decimeter radars to the 4 cm range radars, the antennas of which are located in the wing. This allows you to launch a rocket in the target location, so that the missile, approaching the target at a distance of capture by its radar homing, makes a targeted attack. Tuchkov notes that as well as the stealth challenges for the Su-57, it also has to avoid detection in the visible spectrum and infrared wavelength range. To reduce optical visibility, the designers of the Su-57 added a pixel color on the aircraft. However, challenges remain to overcome the thermal or infrared visibility of the jet. Despite the numerous delays to the production of the Su-57, the Defense Ministry and the Sukhoi Design Bureau retain confidence that, in the future, Moscow will introduce a genuinely 5th-generation stealth fighter aircraft.